Hey there again. Glad to see you back for the second video in our series on reducing stress through design. Before I go into the topic today, I just wanted to reassure you that between the time I made the last video and now, my hair hasn't turned completely white due to some horrible fright that I had, like seeing a ghost or some such. In fact, it is just the skylight setting my head aglow. Okay. Now that I've put your mind at ease, we can go on to the topic, which is the spec file. Now, here's the situation. Let's say you create processes that generate files. You write tools that need to consume that data. Let's say one stage of the system might even generate files that a next stage consumes. So the question is, how do you manage this data in the files? How do you keep track of what's where? How do you name the file? How do you name the directories that the file goes in? Well, a common first thought that occurs to people is, well, I'll just put a date in the directory name or the file name so I keep track, or the date and time, or a sequence number, a one-up number. Another thing you can do is you can put into the file name or directory name some information about the parameters that were used to launch the process. So let's say you write a process that takes one argument, like the number 9. So you could include that number in your file name or your directory name. But what if each run involves lots of parameters, too many to put into a file name? What do you do? Well, there's a design pattern that I keep getting pulled into pretty much every project that I've worked on in recent memory. I've always gravitated to this pattern, and it's simply using a config file, also known as a specification file, also known as a spec file. And this file contains all the parameters for that run, everything about the run that you might want to remember. But now you don't have to remember it because it's living somewhere in a file. And what happens is you write the process to take the path to that file as the argument, and you pull that stuff in. So you're likely familiar with config files. They're used all over the place for various reasons, but there might be something novel about how I deal with them that might give you something you can work with. So let's see, where do we go next here? Okay, so the advantages of this, there's less to remember about what did I do in that run? What were the parameters? You can go find it. It's easy to find. You can create a cleaner and easier to navigate file system, less confusing, because what you can do is you can use the info in the name of the spec file as the name of your output file or directory name, or maybe the root of a tree. So the way I do it is that I have a spec file named in a certain pattern, and a portion or all of that spec file name gets used as a subset of the root directory under which I put everything. And so it just keeps it all organized. There's no confusion about the vintage of what data. I may use the date in my spec file name, and so the date will percolate through the system. In fact, I think, yeah, I pretty much always do that. So let's look at some examples here. So here's an example of the spec file that I created for my last project. Now, I rolled my own spec file. I didn't use any of the standard wrappers because I knew I was going to want to have things look extremely simple for my eyes. And so I came up with a format that was unique, and I wrote a little wrapper class that knows how to load this up and provide all the information in it. It's pretty simple to do. Probably took me 20 minutes. So let's see what I have in here. Basically, I just have each line as a declaration, and I have some character that I can parse apart with a split command, the string split command. I have my class look through the file. Is there any line with a controller in it? Okay, what is its argument? Save videos, yes or no? Test set. This is a concept that I came up with for organizing the test data. And this lets me say, I'm going to use these test sets in this order for my test run. Now down here, in some of my other videos, I mentioned this project involved scenes, running scenes. Turns out there were a lot of different types of scenes. And here's the code name for those, IOP, lava. So I came up with a do type configuration entry where I could just list each one that I wanted to do and just comment out the ones that I didn't want to do. And let's see, the final bits in this is I have some lines that contain information about the apptainer containers I needed to generate for this project. So let's see how this is used. So I have chosen the naming scheme here. The first part was which project, which sub-project this was. We had 3. So enter was one of the project names. Then I have the date, and then I have a little comment that gave me enough information about this to know what the context of this run was. And so, I don't want to make that too long. In this case, it was eval 7. It was nice and tight. I'll show you more config files. Actually, I'll just show them to you now. So let's see, what do we got here? You can see all the different runs I ever did for all my, projects here. I had AVOE projects through time. I had inter-project runs. This is 3 years of testing, basically, on different code drops that we had. So it's just really easy to navigate that space and find the one you want. Okay, so I'm going to show you the code that consumes this, one of the pieces of code that consumes it. So I have this optics program, and all I'm going to show you is the usage line. Let's see, where is it? Okay, here we go. It's in fact a little bit long. Let me just go there. Okay, go a little bit shorter. But so I have one program called optics, and it takes an argument. And this is the thing that's going to happen. But the other argument is a config file. So all of my command invocations have 2 arguments. They have what's going to happen and the config file that has all the parameters in it. So the optics program I wrote does a whole bunch of different things. It runs a test manager. It runs a test runner. It has a utility to stop runs. It can generate scores. It can erase results. It can do all sorts of different things. And having this optics config thing is simplifying because for each of these, I just load it up into its wrapper class instance, and I just pass it down. And whatever process gets it, reads whatever it needs to get. And so what this means is that all of the function calls I have are tight because they don't need a bazillion parameters. You're just passing the config spec down the line until some function needs something from it, and then it can just look it up. Okay, so let's look at just one example of this. So let's look what's going on here. So I have this class, and I'm instantiating it with the argument that is the spec. And then I get the project name from this wrapper class instance. Now in this case, the project was derived from the file name right here, the file name of the spec. All of these statements are instantiating directory names that are based on information from the spec itself. Any code that needs to find one of these directories, all it needs to do is instantiate one of these by passing in that, and then just consulting that. So a very tight sequence of invocations. So the real payoff here is that here I am, say, 3 years into a project, and I've generated a ton of information. There's no confusion about where that information came from, when it was created, what were the parameters that were used to create it, It's all easy to look up. To summarize, using this approach, you can create a file system for your project that's less confusing, where you can know where everything came from. You can know what parameters were used to generate this data by just looking up the spec file, because which spec file to look up, the name is encoded in the name of the files that you generated, or the directories, and every artifact that's created has that little identifier writing along. I had the output of processing scene files under there. I had the logs generated under there. I had the Apptainer containers that were used to run the scenes named with that identifier. So wherever I looked in the system, there was never any confusion about what files belonged with what run. It's a really nice way to go, because it would be stressful if you needed to find something and you needed to remember what happened and you don't have a good record. It means you don't need to keep a notebook where you're writing all this stuff down. All the information is just embodied in your landscape. It's a self-documenting approach to data management. All right, that's the spec file concept, aka config file, aka whatever you want to call it, but it's a really great pattern for reducing stress because you always know what's going on, you know where to find things. All right, we'll see you in the next video.